Welcome to the Capstone AI Lab for the business leader. I'm not going to walk away from telling you the complex things. Other than the classification, there are at least three kind of neural networks, which is the feed forward, the recurrent, and the convolutional neural network. So you will hear that CNN and RNN. Feed forward is kind of the older way by which it all got started. So you don't hear much of the feed forward. So I'm going to go back to my deck. Okay. 1 second. Yeah. Sharing back again. Okay. So the way the whole neural network started was with feed forward, which was basically you hear about this concept of layers. So what a better way to understand layers is to go back to one of our familiar videos that I've shown this class. Let me go back to that. So if you're looking at this flower, and this one is from Google. Again, I have no affiliation. I bring you the best possible examples because these are all public ones. So I want to give them credit for doing a good job with this, but I have no affiliation. So this explains how computer vision works. Forget that it's computer vision. I just want you to understand this whole concept of layers. Okay. So here is a flower in a background. As humans, you look at it, immediately you see the flower in this whole picture. This portion is blue, there's a fading, there's a lightish green, there's a little more blue, all that in the background. And then you see the petals specifically. You see the stem, and you see the center, a lot of yellow. So as humans, we tend to just go and look at what is different kind of layer. We understand what it is. And for a computer, this is just a grid of numbers, different colors. And that's what it's doing. So the whole concept of layers is if you feed this to a computer and make it run once and scan through these numbers and say, okay, I see 95, I see 122, blah, 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 blah. And then it sees the white. And it says, I see white color here. And it starts collecting that pattern. And it will try to figure out what it is. So this is, computer vision is usually doing object detection. And for object detection, it needs to understand what the shape of the object is relative to its background and separate it and map it to what it has already understood as a flower, as a stem, or the pollen. So that's what it is going to do. Do you remember the exercise I've done with you of talking to an AI where it does we did the Google Doodle? And it says, do you guys remember that? Yeah. So it's trying to look at the doodle and it's trying to understand what it has in its memory of its learning. So that's what it is doing here. Doing the same full screen thing. When something is in full screen, when I go back to share, I get into trouble.
Algorithms to understand image content in the same way that the human brain does. And to make this work, we use an algorithm very similar to how the human brain operates, using machine learning. Machine learning allows us to effectively train the context for a data set so that an algorithm can understand what all those numbers in a specific organization actually represent. And what if we have images that are difficult for a human to classify? Can machine learning achieve better accuracy? For example, let's take a look at these images of sheepdogs and mops, where it's pretty hard even for us to differentiate between the two.
Do you remember we did this train with Google and we did this dog versus dog mop? That's an exercise we've done. Again, I'm happy to give you the links for it and play with it. And if you want to do this, I don't want to take away time today because I think you guys know this stuff. Yeah. Okay. Olga, did you say you wanted to talk to do the chat with the algorithm? Is that what you want to do? What was this? Yes, guys, I'm sorry. I'm missing out on that. Do you want to do the talking to the model piece?
No, no. I think at least I remember this exercise that you had done.
So you've done, yeah. So you've seen the dog versus dog mop, but Olga, did you want to do the talk to the algorithm piece? Is that what you were saying? Yes, for talk to the AI.
No, I was also like Anaya. I write that I remember the.
Oh, you remember that. So the yes was for the remember. Okay, thank you guys. So we did the talk to the AI and you say, I see a circle, I see a rainbow, I see your shoes. Oh, I get it. And it'll say something. And I have the video of that and I have it in the class sessions also, but I can share that back. I just wanted to recall that because that's what it is doing, right? When it is doing the CNN layers as a neural network, that's what it is doing. And we did this dog versus dog mop, right? So it's the same thing. Okay.
With the machine learning model, we can take a bunch of images of sheepdogs and mops, and as long as we feed it enough data, it will eventually be able to properly tell the difference between the two. Computer vision is taking on increasingly complex challenges and is seeing accuracy that rivals humans performing the same image recognition task.
Okay, we've seen this where you do the apple versus oranges and then you put something else. When you do a binary classification, you just say two things. That's all it knows. When you bring a absolutely unrelated third thing, it will try to fit it into one of those two. That's a very important thing. So when your data scientists say it's fantastic, it has 99% confidence, it means you have one model saying dogs, another model saying sheepdogs, and within the two, if you feed another one of those, it can give you with 99% confidence. That's the performance of the algorithm. And like I said in the beginning, if you feed it a donkey, it is going to fit in one of those two with a very high degree of confidence. So you have to understand the confidence of the model in perspective related to your business case, and it's your job to break the model. Give it data to break the model or see if it breaks the model. And if it doesn't, hey, then it's really a good algorithm. Or you have an opportunity to do some feature engineering to train the model better to make it work for your situation.
Like humans, these models aren't perfect. They do
Okay.
is called a matrix of pixels.
Okay, let me go back.
A specific type of neural network that accomplishes this is called a convolutional neural network, or CNN. CNNs work by breaking an image down into smaller groups of pixels called a filter. Each filter is a matrix of pixels, and the network does a series of calculations on these pixels, comparing them against pixels in the specific patterns the network is looking for. In the first layer of a CNN, it is able to detect high-level patterns like rough edges and curves. As the network performs more convolutions, it can begin to identify specific objects like faces and animals. How does a CNN know what to look for, and if its prediction is accurate? This is done through a large amount of labeled training data. When the CNN starts, all of the filters.
So remember we said this is again feature map because it is basically taking this is eyes. And so you need a lot of data which identifies eyes in there, different kind of eyes. So when we do facial recognition, the eyes is the first thing. In olden times, they just identified eyes. Based on the eyes, they would identify a person. And then they would say, oh, the cheekbones are different. So that's a different feature. Then you need to give images in your training data set, which has different kind of eyes combined with different kind of cheekbones. And then it's done, right? Now, if you have two people who have similar eyes and similar cheekbone, it can't differentiate between the two. Now you need to have a more feature map where you say, okay, now this person has a pointed ears. Then you find somebody with pointed ears and somebody who doesn't have pointed ears or a different kind of ears. And then you have, so that's what is called the feature map. You have more, you identify specific features in that it needs to identify and make sure that is fed in your data. So essentially it's a lot of work on your part to make sure that you have, you feed the right data so that it can identify. For images, you can visually understand. For just data sets that it's going to do map scans, it becomes harder. So you will have to say, this is the customer who is from, who's not a CEO, who is willing to travel. This is a customer who's a CEO, who can travel because the distance is close. So that could be your feature map. So you kind of create different kind of customer types and make sure all of them are covered in your enough in your data. And so when it runs, so when it does layers, it's scanning through the whole data once, trying to understand something, and then it runs again, it will do it. And those are the different layers.
Values are randomized. As a result, its initial predictions make little sense. Each time the CNN makes a prediction against labeled data, it uses an error function to compare how close its prediction was to the image's actual label. Based on this error or loss function, the CNN updates its filter values and starts the process again. Ideally, each iteration performs with slightly more accuracy. What if
Okay. So I want to stop here because she did, I hope that whole concept of doing it in layers is what the whole neural network is. That's how our brain is supposed to work in layers. So we look at something. So if you're reading, even I found that, I was trying to get the IBM Auto AI. I went, tried to set it up, tried to watch, understand what they're saying. I understood something, but then I could not do it. I went back, watched the same thing, read it again. I didn't even go to new resources. I just went back and read it again and say, what are they saying? And then now I understand a little bit. So that's how we intuitively learn, by capturing more things. And the way we learn is we actually take that and map it to something we already know. That's why if you who are, are experienced already in industry, it looks like something new, but you can learn it faster because you can say, this API, that's what they're doing. And I've seen it in the non-AI world. And there were this, there were these APIs and platforms, and you'll make that connection. Or you can say, hey, they are giving this model, and Akio says it's no code AI, it's free. But then for me to keep using the model, they're going to charge a penny every time I use it on a usage-based model. I've seen this somewhere else in a different world. So you can make that connection. And that is what the CNN, the neural networks are doing. They're doing it in layers, layers, layers. And the layers are not just tens or 20 or hundreds. It can be in millions. Millions each time it's scanning the whole image or the entire data set once, trying to claim some knowledge. How do we know what it has learned? We'll test it and say, okay, you've created a model. Tell me what you've seen. If it can only do an outline of the cat in a bowl, it's not going to identify cat or a bowl. It's going to say something. And it's absurd. So you go, okay, do it again. It runs again. And now it understands and it says, I understand. It can do a little better. How do you define the little better? By giving it data and testing it out. So that is what they call as loss function. So what they do is they'll say, okay, was it able to identify compared to the image that I gave, and that they define as an error. And we don't need to know it from a business perspective when we're doing this, but these are jargons you will hear. It's called loss function, the error rate. That is a word that you would see the data science people use it. So there are two words. One is called learning rate and another is called loss function. I'll get to learning rate in a minute. So they basically do that in layers, scan the whole thing and see, and test it and say, okay, it's not anywhere near accurate. And so the loss is very high, the error rate is very high. So now I want to refine it. Let me redo it, another layer, do it again, another. That's how it runs millions of times. And so when we hear about, hey, the algorithm is not explainable. There was this Uber case where the driver got fired and they sued Uber. Tell me, what was the factors based on which you decided? Were you racist? Were you discriminating me on something? Because I'm a good driver and you call me a bad driver. Your algorithm is buggy and you need to, compensate me for the hardship. And if they had this CNN layer, which looked at all the driver behavior data and understood who was a good driver and bad driver, they won't be able to go back. And so there's a whole field called explainable AI, which is basically another AI querying this AI to see how it is making decisions and saying, it looks like this is an important factor. Whether the driver always got a 5 rating from the customer, whether the driver always did not cancel their trips ever, or some factors in the data, right? So they could say this is based on which. Now they can go back, if they make it explainable, they can go back and say, now we can tell you these top 3 factors where, the decision factors. So you could be working in legal and you might be dealing with a case where they're trying to sue the company. And so you need to know what were the factors that they used So you need to have that. But the way they, when they think about this, when they built it, is they'll do it in layers, 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 and they're trying to get to better accuracy. And they use this loss function. And they'll say, so if they did, instead of, million layers, if it's a new company, they're getting started, they don't have the time to do the million scans layers, and they're just saying, we'll run it 100 times. I think I can predict it. That's like the apples and orange algorithm predicting a donkey. So you might not see it unless you feed a donkey to it. And so that is where the algorithm efficiency is low, but it will say I have a 99% confidence. And so the loss function is by when you feed training data to see whether it is predicting correctly, and there's a huge error rate, that's called loss function. So the goal of the algorithm is to reduce the loss function. So the whole concept of feed forward, let me go back to my slide. So it started with this concept of feed forward, where they said there is an input layer. So they said there's an input layer. That's how you feed the data, right? That's the first layer of the cat picture you give. And then there are many, many hidden layers because you don't see it. And then you see the final layer from where it is making the prediction, right? So it is scanning, and it does the first round scan, and then it scans many, 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 many times. And then it makes the final scan and it says, okay, I'm ready for you. So that is what they did as feed forward. So the original networks were feed forward networks, which means it started with the input layer, had some hidden layers, and it had an output layer. You could not see what was in there. It just said, okay, here's the output. So then they changed to newer types of, they built on this. And this is where we are. Like all of these are neural networks, right? This is the video I showed you. You can go play with it. They could do this with image, which is computer vision is done using neural network. They could do that with customer data also. So you could have huge volume of data. So if you take a company like Verizon or something that's, or Google, from looking at all their search algorithms of past years, they're going to have huge volume of data. So when they're training to build a search algorithm, they're going to have huge volume of data, and they need to do a neural network. Even if it is structured data, they cannot just do simple machine learning. So the easiest definition you'll hear is structured data is machine learning, unstructured data like images and voice is deep learning. But this is what I also said that a couple weeks back when we covered the basics of this. But if you have huge volume of structured data, and you don't know which column is actually the important factor that is determining the outcome that you're looking for, then you could do deep learning neural network of this structured sheet also. So more and more you find neural networks being used for machine learning also. So it's not just limited only to deep learning. Okay. And we saw this the feed forward. What they did originally, this is a neural network, right? So in feed forward, they started saying input layer, output layer, and then they had all these hidden layers. It was just one way. And then there is one called um, recurrent neural network, where it just doesn't do this one time. They basically give it some kind of reward, saying, okay, how do you define what is a good performance algorithm? What does it look like? And so they will give a reward to which it is running, that the algorithm will keep on it. They won't say you have to run this 100 times, 1,000 times. This is, and they can't keep on testing every time. So what they will do is they will make it run and go back and start again. But it has to keep doing it till it reaches certain loss function should be less. The error rate by which it makes the prediction should be really good. So they would feed a certain loss function, and based on that, they would make it keep running. That's the recurrent neural network. So for our purposes, we don't need to know all the inner workings of it, except that when they say loss function, we know what they're talking about. They're talking about the gap between the prediction, how the error rate between the actual prediction of what it should have said and what it actually came up with. So when it just saw the outside of the bowl with the outside of of the the boundary of the cat, it's not going to predict a cat, and it's a very bad loss function. And what do you want that to be minimized to? is what it's going to run towards. So we've seen how, the computer learns games, and AI does this game. It did the Go game. It played and it won against the master who knows to play that better in the world. The rules of the game, they did not give the rules of the game. They did not say this is how you play the game, these are the different strategies. They just fed it years and years of how the data was, how the game was played and won and lost, because you need winning and losing data. And it created its own combination of strategies, and then it beat the human. And that is done using the whole neural network, and it is using RNN, or recurrent neural network, where the reward function the is that if you do this combination of moves, then it's a win, and this is how it's going towards winning. And so it runs all the combination in its head. When it's running all the combination, in the past we used to think of it as rule based. Now what it's doing is layer. So the way it is doing is it's doing one layer of learning, saying I've seen all the videos of how the past games were played. I think I understand the rules. And then it is internally, it is tested, and it says has made an absurd assumption. So think of this: if an alien came into the world and is watching a baseball game, they wouldn't understand what it is, and they will say, hey, these four people are just standing, and this group of people who are just watching them. And then, um, and somebody uses the stick, and they're going to make sense. Or even if one game, for me, I came from India where we played cricket, and so learning baseball was, I had to literally not translate, I had to unlearn. Like, I had to say, that's a different game, that's not what it is, this is a different game, and that's how it is. And I had to learn the rules of it. And nobody sat and taught me this. Or somebody who knows the game totally would just give me the basics, right? And they would say, hey, it's a home run. And then I'm like, what's a home run? And everybody seems to be, excited, and I see a pattern. If I see enough of it, I'm kind of going to get that. So that's how it is. Think of the computer as like this alien watching a soccer game or a baseball game, or something like that. And they're like, the more they watch, they're going to understand, especially if they are going to. And so the feed forward network is watching to understand how this is done. The recurrent neural network is watching to win. So now if they are going to watch and say, what is the strategy they are following, and not just the rules of the game, so that I can actually win, because the goal is to win, and winning means you get more points, more score. And this is the ways by which I get the score, and this is ways I get penalty, and this is the way I miss an opportunity to make a score, things like that, right? So those are different layers, and your factor maps should be teaching it various things. So there's a lot of AI in sports these days, because all the games are recorded, and then they actually take the close video of every player when they play different games, for tennis, for all kinds of things, for golf especially. I've seen a lot. What they do is they in fact they have these multiple cameras to capture it from various angles, and they put this together like a VR environment, and they have that, and then they analyze it using this whole um, recurrent neural network model. And they will say, okay, so now based on that, this person made a mistake, and he was having his bat at this angle, and he could have done it this way, and this compares with somebody else who did this in 1927 or something like that. So they have recommendations for players to improve their game. They have a recommendation for coaches to look at who's done what and how they're improving. So there's a whole movement in education to have algorithms look at what students have understood or what they've not understood. So think of the videos here. We are talking, and you're learning. We are having some discussion, and then you go back, watch the videos. It can track which, or you might do some exercise, and you do some things good, you do some things bad. Based on that, it can say, Ananya seems to, I'm not picking on you, but I'm just giving an example, seems to actually run into issue every time she does some kind of recurrent neural network. There's some gap in her knowledge. So then it can actually customize the person's learning and say, this is the gap, and this is she sees there's a certain pattern of mistake she does, and this goes back to this. If she learns this one thing, then everything else will come together. So we could personalize the learning of people is kind of the holy grail. I am personally not a believer of it because I still believe in the value of the teacher and the human factor. I think it's in math, you're learning some problem and you're running right giving a quiz. Maybe you could do that in a linear fashion. Something like our kind of topics of learning things, I think it's next to impossible. But there's a whole movement to get education automated, and there's a whole bunch of companies who are building algorithms for that. So I don't know if you will run into one of them. If that's your thing, go for it. Okay. I want to pause since our goal here is to learn the basic classification models, because that's what we are going to fit. I did not want to cover deep learning at all, but I did not want you to walk out of this course and say, I learned to build an AI, I've done the data science, and somebody throws a jargon of some neural network and RNN and loss function and whatever, right? I didn't want you to be at a loss and say, maybe that's something, one more thing. And you don't know that it's not it's not in the 7 classic machine learning algorithm you needed. It's a different thing. Especially they will say supervised or unsupervised learning, machine learning or deep learning. And that's a common thing you hear. So that's a very foundational piece. I don't want you to be at a loss. And I don't want you to be at a loss when you're having a conversation with a data scientist feeling, I don't know. And this, they don't talk about feed forward. In fact, in the McKinsey link that I shared you, there are companies who are doing feed forward. So where is that link? The visualization we did. And I want you to play with this. I want you to come and ask me questions. I want you to think about how you will use it for your own applications, or where you want to pivot, what you want to do, what's interesting for you. Okay. So we saw the 7 classifiers, the classifiers, and based on that, we saw this. They also had who is using the feed forward. Let me take this off. Who's using feed forward neural networks? And here we found a bunch of companies. What are they doing? They're doing that for supply chain management. They're also using that for marketing and sales. I wonder what they're doing. So a lot of it is customer service management, the next best product they will buy to provide an individualized offering, yield prediction. Interesting. I don't know why supply chain management and manufacturing is using feed forward. I would like to find that, guys. Oh, they're not selecting only feed forward. Okay. I wanted to see only feed forward whether they're using. Because they checked off the whole recurrent neural network and convolutional neural network and everything, right? Different kind of neural networks. So for all practical purposes, you don't need to know which kind of neural network. So deep learning is done using PyTorch or TensorFlow. And I think most of them are convolutional neural network, which is like a crisscross, and recurring neural network is when you give a reward function. Okay. Okay, it's taking forever. So I'm bored. So I'm going to get out of here. Okay, so you get the idea. You can play with this and it'll tell you which company is doing what. I want to go back and see who is using just feed forward neural network in here, because my understanding is it's kind of a past thing, and nowadays everybody is using convolutional neural network, which is kind of a different way of doing it, and RNN is a reward-centered way of doing it. But they're all neural networks, they're all deep learning. That's all you need to know for all practical purposes. Yeah. Okay, questions, comments before I go to the next topic? Can it move forward, guys?
Yes, absolutely.
Okay, so that's the neural network. So before I close out this topic, if you remember right, we said all algorithms ever done is going to do only one of these, right? So the recognize objects is usually to identify the object, so that is computer vision. So it says, hey, here's a tomato, or here is lettuce, or to identify that. So again, we are not doing that in this course, but I just want you to know that object recognition is our big thing in self-driving cars, and it is using computer vision. And the sports example I gave you is actually done using computer vision, because they're looking at images, and anything you're looking at images and videos, that's computer vision, identify objects. The other thing that I am not covering in here is the fourth one, which is anomaly detection. So the typical algorithms by which you can mostly get work done is you ask for a prediction or recommendation or classification to understand customer behavior and things like that. That is grouping and classifying. That is done using classification. The anomaly detection is a totally different thing. Amazon has an anomaly detection algorithm, and again, all of these, right? Amazon, IBM, Microsoft, Google, and then there are like hundreds and hundreds of software startups out there, AI startups. They all will give you an algorithm. So there is one company called Anodot, and I had covered them and how they did anomaly detection and did some kind of customer churn model in one of my weekly Wednesdays. So it is there sitting somewhere in our weekly Wednesday. And Microsoft has an anomaly detection model. So anomaly detection is to just find the odd man out. So, so the thinking is, this is all the data, right? So it could be fraud, your credit card fraud that is happening, and you're saying, I want to find an odd behavior, and you say, here you're withdrawing this much money, this much money, this much money, and then you say, hey, this looks different. Suddenly the person is used to withdrawing $50 and $100, and not suddenly they are withdrawing like $1,000. And so the credit card company usually will put a hold on it and say, did you do it? They could do that saying, is this the customer lives in San Jose, that's me, and now they're suddenly shopping from Barcelona, and they could say, hey, put a hold on it and don't let them buy that coffee. And you productize this experience and give an app and say, hey, you can actually validate it's you, and then we'll let you go, and then we'll release the model from stopping you. That's how the productizing aspect comes in. So for the purpose of building the model, you're going to actually take your data set. This is customer purchase behavior. In my case, a lot of credit card purchase from the past that each of my banks are doing. And they are going to have somebody on the business side define a metric saying the customer's location is the metric. And if the customer location is not San Jose, that's a problem. If it could be from San Jose, maybe I went to, they might have a certain distance that I'm allowed. Remember the example of the customer living so many miles away from Chile that we had in the other data set. It's going to be something like that, but you are going to decide how much is acceptable. If I never leave San Jose and I'm always buying only from San Jose, even if I shop in San Francisco, it's an issue, but usually they're not going to do that because it's not customized just to me, right? They're going to say the average customer drives around 40 miles or 100 miles, and within that they can make a purchase, it's okay. Or if they leave the country. So usually the credit card companies look at it as leave the country. It is actually, I can drive up to go to Mexico than drive up to go to Boston. But they will stop me if I go to Mexico. They won't stop me if I go to Boston. It's just crazy because somebody decided an anomaly detection based on country. So that's a metric that you decide as a business person that you're watching for. The other thing is, okay, so different locations, different time of the day, based on past behavior data, you're just looking for anomaly. So if you think about it, for the purpose of this class, we are not actually going into the lab exercise with anomaly detection, but it is similar to what you're doing in your customer, understanding the customer behavior, because essentially you're trying to understand the customer behavior, exactly like what you're doing when you're marketing use cases. But then now you're actually trying to find the odd man out and say, that's an outlier. This is not the behavior of the customer. And typically it is not one metric, it's a bundle of metrics, and defining that bundle of metrics becomes a problem definition that is done by the business user, because you need to know your business and you need to know your customer, and then say, okay, this, it's not just the customer is buying this from at a different denomination, but the customer is used to withdrawing money on an average, once a month, or maybe they do twice a month. But within 1 hour, if they're actually going and buying from 3 different locations, that's a problem. And then that's an anomaly, detect it and make sure that the credit card is not stolen. So I had the situation where I went to Bank of America to withdraw money, and they decided to make that ATM into some kind of touch screen setup. And they said, hey, do you want it in this denomination? And I said, yes. And they said, do you want it in 20s and hundreds? I started playing with it. The touch screen at that point didn't work for me on that ATM. And so I could not get it in the denomination I want. So I canceled that. And then I tried again, thinking I made a mistake. And then I ran into the same situation. I canceled again. And then I realized that that ATM is at fault. And I see next to me, another lady is using another ATM and she's able to do her thing. So I went to the other ATM and I went through the same thing. And at that point, it logged me out and it ate up my card. And so then it basically checked for anomaly and saying, hey, it is not a common behavior that you're trying to use the same ATM twice, and then you are using the next ATM. So this looks fishy, and let's stop her. And that is something that they did. And it was a product, right? They created a new product. So the interesting thing to think about is, yes, you might be just helping them create the AI model, and that could be your calling in the company. Then you have to think about this of different outliers. And then you have to think where it still could be a real legitimate customer. How do you give them relief? And that could be your product layer that you're building on top of that. The other thing is, in this case, they actually launched the new touchscreen. They must know that for some percentage of users, something could go wrong. The touchscreen might not work. In fact, they had this thing, if something goes wrong, it doesn't work for an ATM, you actually call this number. I diligently wanted to call that number and notify them that that ATM is not working, because I'm one of those people, and because somebody else is going to run into a problem like that. But they should have had that system connected back and say, hey, I'm getting enough customers complaining about this ATM touchscreen, and we are seeing data from an outlier of people using this particular ATM multiple times. But that was missing in their algorithm, because somebody who created the anomaly did not do that. So I want you to know, classification, segmentation, making prediction, recommendation is what you're going to do 99% of the time. You might work in an industry like finance or looking for some kind of anomaly detection as you're living, and you might go contribute to that. Then you need to be aware it's still doing the classification and organizing and everything, but it is taking some kind of anomaly metrics that you're defining, bundle of metrics, and trying to catch the odd man out. So it's doing a similar thing, but it's doing that. So you're not going to find the same common algorithm that the data scientist is going to do. Your data scientist is going to say, I don't have an algorithm for anomaly detection. I need a new tool. The people who will be able to just fit the algorithm and make a prediction, you'll find those data scientists easily. The people who can do anomaly, you need to hire them, and they'll say, hey, I know to do this only with Anodot. I know to do that only with Amazon or something like that, right? That also might be a expensive exercise because they don't have enough people doing anomaly detection. And so you don't have, so the technology layer of finding anomaly is what the API, right, that Amazon is giving or Anodot is giving. And then you might build a fraud protection model for your bank. You might build a spam detection filter for email, things like that. So you might want to identify a different kind of, where the pattern is different. And in that case, you might want to use the technology layer, and then you create the business layer separately, like we said about the 100 trillion versus the 14 trillion, the technology AI market versus the applied AI market. Okay. So the last thing I want to do in the models is actually get to the specific models. before we actually learn how to do the models. So, and I've actually covered this. I've jumped ahead a little bit though. I talked about it. So what we did today was we said, hey, all models are going to do this, one of these four, what machine learning does, and then what deep learning does is neural networks. We saw a video explaining the different layers. Computer vision does the object detection and anomaly detection. These two we did not cover in this particular Capstone Lab exercise. So we are going to just our basic what we were doing. So is your data training data structured or unstructured? Really doesn't matter, but it's a very interesting trivia. You will be asked anytime you say you know data science. So I've already covered this structured, unstructured, supervised, and this thing. So this is what a data scientist is learning. When they are learning, they are not learning that it does four things. They are thinking, they are taught the type of data science problem is either it's a classification problem, it's a regression problem, or a clustering problem. That is how 100% of data science, maybe 100%, not 100%, at least 100% what I've seen, does this. So you are expected to learn it's supervised, unsupervised, and whether it is classification or regression. This is where you would end up most of the time. So I just want you to be aware of what that means. So supervised is it's structured, you already have the answer for the existing data set. Unstructured is like you don't know what is going on. You would like the algorithm to group and segment and organize and show you some pattern in there which you're not able to see. So the COVID testing, and you're looking at whether the customer has COVID or not, and you're seeing blood samples, it's actually looking for some kind of unsupervised learning. Yeah. And it's so classification is where we are hanging around for all our learning purposes. It's some form of supervised learning, which means you think of supervised learning as you're the supervisor, you already know the answer, and so you're basically letting the algorithm saying, I have the existing data, I look at the existing data, I can see what's going on, and I know what is right, what is wrong. Now I want you to extrapolate that and tell me more. So a simple classification algorithm is classifying as into it's either a binary classification, which is one or two, or it is a multi-class classification, which means it could be based on multiple different categories. So if you're going to say, is the email spam or not, or is the customer buying or not, is the customer churning, yes or no, those things, it's a yes or no, you're expecting that. Even in Jose's case, is this muffler going to blow up, yes or no? If that's how he's framing the question, he's framing it as a classification problem. So see what I did there. By you framing the question, you can actually make it one or the other most of the time. So customer churn is something that you can actually frame differently based on which different algorithms are needed to solve. So if you're going to look at the list of customers and say, is this customer going to churn, yes or no, that's a simple classification problem. If you're going to say which set of customers are going to churn, and let me help you understand what kind of factors in their demographics contributes to them having a propensity to churn, then that becomes a regression problem. So that's the big difference. And you will be expected to know classification and regression. Regression is a linear algebra terminology. You don't need to know what it is or the brains of it. You just need to know classification is going to be a point, yes or no type of thing. And regression is going to be a forecast or prediction, right? It's going to be like over a time series, look at the data and say what is going to be the stock market price. So if you think of an example as yes or no spam, churn or no churn, then it's classification. And you say, okay, now let us predict or make a forecast and tell us what the number on a continuous series, then that's regression. And so the underlying algorithm is both. And again, it gets confusing because you're doing classification, but they're doing logistic regression, and you're doing regression, and you're doing linear regression. So for all purposes, we don't need to know that, but you might be faced with that. And you say, I don't understand regression. And now they're saying it's linear or logical and logistic, and I don't care. It should be your answer. You cannot say, I don't care. You need to know this is classification or regression. And the other thing is clustering is grouping. And there are various different algorithms. We looked at just the base. Some of the k-means is one of those algorithm which does grouping, but it's like find similar pattern of algorithms which are fraudulent algorithms is the example they're giving. And otherwise this could be done using unsupervised learning, using CNN and layering and arriving at groups and say this group of customers looks like they are um, doing some fraud. And remember when Emma came to our class and did the GraphML lesson, she was doing this clustering. And she said, this group of customers are the ones who seem to have stolen the phone, and they look like they are doing some fraud pattern. And so based on that, we can identify similar people who are fraudsters in our data set while it is happening and catch them. So that was the clustering piece. And then, so you'll hear this again. This is machine learning, could be supervised, unsupervised, and the clustering. And then I've said this many times today. So predict yes or no situation. So give me an example from what you have seen. What's a binary classification? And is your problem that you're dealing with, is it binary classification, yes or no?
So for Innovatech conference attendees,
Yeah.
so whether each attendee will purchase the ticket again in 2021
Yeah.
based on their behavior in 2020 or 2019,
Yeah.
sounds like a yes no with a percentage of confidence.
Yeah.
Uh,
Yes. So
yeah, so forecasting would be how many of
yeah.
those,
And
right?
which factor is going to contribute, which factor is
Right.
saying, whether they're living here, living there, whether they have this kind of title, all those things. If you're going to peg it on a particular factor, then it becomes a regression. Otherwise you can just do simple. Okay, so if you framed it as a yes or no, and you have a column saying yes or no they are going to buy, then it's a very straight simple classification, binary classification.
Yeah,
Okay.
but in the case of our data, you can look at the clustering at first,
Yeah.
And then go through the different permutation, because I think one of the, I was looking at, and you put it together in a spreadsheet, but there were, like, for instance, a lot of titles.
Yeah.
And I don't remember exactly the numbers, but all those titles can be clustered into high level, mid level,
Yeah.
bottom level of a job.
Yeah.
And
Yeah.
so I mean, I think is there something that we should ask Kajal to do in terms of, okay, you have multiple names,
Yeah.
and then and I think that's a kind of an open field, so it's anybody can write down whatever they want to write,
Yeah.
compared to having a specified specified category.
Yeah.
So I mean, if you do the clustering, is that going to be helpful at all, or you're looking clustering more on the output side?
Good question. So one is, if you have a column, if you add a column, so that actually raises a very interesting power you have as a business person. If you go to the data scientist and say, here's the data I have from the past conference, and I've added a column which says they bought yes or no, and I have historic data. Now can you run a model? It's a binary classification model, and you'll say they'll buy yes or no, and they'll give you a model. Now you can take a new customer and feed it and say, are they going to do, yeah, are they going to buy yes or no, is what your model is testing for, right? And they give you the inference model. The second way of, remember we went through this whole problem statement of defining the problem differently can lead to different models, and within that you choose different use cases, because finally your business goal is to increase the revenue by 10%. So if understanding the existing customers, whether they're going to buy yes or no, because you're going to run a because you're going to run a campaign on them and saying, here guys, early price for people who have already been to the conference, and I'm opening it up first for you, and once you're done, and then only I'm going to the next set of people. And if you're running a campaign on the existing base, then that whole binary yes or no, it becomes important, right? If you're actually trying to understand the customers so that you can get more customers, then you can go in one or two routes. One is you can actually run a regression to see which factor out of the columns that defines them is important, that their CEOs is important, living in Chile is important, that they are a repeat customer is important. What column is actually going to be the key factor? Filtering that, you get, suppose you have 10,000, customers, and you're going to make somebody call them, and you're going to employ people to do that. So you don't want to employ people to call 10,000 people and say somebody bought, somebody didn't. Eventually you got your 10% increase, but it would have increased your cost in hiring all these people, and you'll take forever. So you want to get 100 people to call. Who are those 100 people? And what is the factor? If you want to understand the factor, you're going to do the regression. If you're going to understand the customer segment from based on what you have in the past, and based on that, you're going to acquire a new set of customers, like a whole segment. So you're going to buy a list, or you're going to go to a whole new market. But you want to see, I want to understand these customers, what are all their factors. Based on that, I can create another cluster like that. So then it would make sense to take your data, and you don't know what those clusters are. So that's why it becomes unstructured, right? So if you're just saying yes or no and you're doing the binary classification, you know the answer with the previous thing, it's structured. If you're just saying the customer behavior based on their demographics of earning this much money, or living in a certain town, or past behavior of being a repeat customer, these factors, you still know the answer. You know the person who's a repeat customer came back and he has a propensity to buy. The customer who lives in Chile, or the person who's a CEO is going to, and you know the answer because you're seeing that person ended up buying based on what you have in the data. So that uh, you're doing a regression, but you're doing classification, right? You're just doing regression, but you're still doing structure. Whereas if you just say, I don't know, I just want to see some pattern in my customers, and it might create different blobs of data, which is different clusters of data. And one set of customers might have a certain behavior based on what it is saying as pattern, and somebody might have a different behavior. And if based on how clean your data is, there might be some overlap. They might be too close. There might be a set of people who could be in this cluster or in that cluster. How do you know? So that's where, having that. So you have to have a purpose of why you're doing the clustering. If you have lots of volume of data, just look for a pattern, and then you say this bundle of characteristic defines one cluster, but these are my loyal customers. This bundle of characteristic defines a set of customers, and they're not reliable. Or this set of clusters is the set of people who will respond if I go by email as my next best click. Or these are the people who will make recommendation to their friends. But you need to have all the data. So it'll just give you patterns that you don't know. And then if you don't know the pattern, so if you're looking for a segment of customers by which you're going to make a call and get new set of customers, you still have to know whether you're doing clustering, which means you don't know what goes into the bundle, or you know what goes into the bundle, but you want the algorithm to fetch that group for you, right? That is the difference, whether you're going to do it as a structure or unstructured. Does it make sense?
This is a huge topic. Another way to see it looks
Yeah.
like when there is a business objective
Yeah.
to recommend, say Roberto, that whether to run a campaign on like with customer retention, I mean, as the goal, or whether to go acquire new. Um, now that we know the what we have promised
Yeah,
for his investment,
yeah,
the data science, could they like just do all three strategies to find promises? I mean, does the auto AI or no code AI kind of platforms allow to do that? Like just like easily
yeah,
find which all these three.
yeah. So usually that's a very, very brilliant question, because that's what the data scientist really does. So Emmanuel, to your point, you should not be thinking whether I'm going to do clustering, whether I'm going to do linear regression or anything. That's not your ask. That's not your job to do. So you need to understand what do you have in the data. You need to be aware of this regression and all that classification and all that enough to know that you have the data to do the job. That's it. That's where your role ends, because your job is to make sure that you have a very clear translation of the business problem to what you want to do. So these are different ways I can achieve that result. I chose this because this is actionable. I have people, I'm funded for this. I have data by which I can ask them to, make a point decision. I have enough data. I have enough volume of data that they can themselves get a pattern. So you could go to the data scientist and say, I have this data. Will you be able to get this pattern? That's what I thought you said you wanted to ask Kajal to do.
Mhm.
So I think with the data that you have currently for conference, you can't do that. It's very little data. You can see a pattern. If you can see the pattern, you don't need the algorithm to see the pattern. You need huge volume of data to see the pattern.
Okay.
That's the thing with unstructured data, because like I said, layers, right? We said the CNN layers, that's what it's going to do with unstructured. So it's going to run one layer and then you'll be done. You don't have, and it's learned everything it can, because you basically don't have much factors or volume of data. Huge volume of data with lots of complex factors. And then it does it layer after layer after layer, like the search algorithm trying to figure out how do I recommend this, and search, looking at all the past behavior of the customer that Google has for so long, right? Um, Things like that. That's why they usually don't do unstructured clustering on spreadsheets of data unless it's huge volume of data. But you could ask your data scientist, hey, is it possible? And they might give you something if it is not too less data. You could go and say, so you, to your point, Nanya, you said, you're talking about three different high level views of approaching the problem, right? You get to decide as a business person, am I going to say yes or no? Make a run, give me that. With your class data, I would say, do a run, yes or no. Add a column which says yes or no. They'll buy yes or, and then run it and see what you get. The worst that can happen is you'll get an algorithm which doesn't perform. You cannot break anything, nothing can go wrong. It will not work because it will have a low recall, right? It will have low accuracy and it won't do a good job. But it will give you an algorithm that's like categorizing donkeys as dogs, right? And it will do it. Hey, it has four legs, it has ears, and it has a body that like that. It looks like it's the same thing. I think I'm going to call it a dog. That's what it's going to do, and nothing wrong with that. So typically, as soon as you get a data, so that's one approach of, if you are friends with the data scientist, you can actually do that. Or if you learn one of these no code AI tools, that's what the Accio people are going for, that you could just try it, because data scientists are hard to get. They might not, they might be in demand, and
Yeah,
so
expensive.
expensive. So you might just want to play with it and say, is there something I can solve? And you say, okay, this is not working for me. I need to redefine my problem, and I have to have different kind of feature. I have to do some feature engineering. Now let me see whether I can run a different kind of classification model, um, and let me see what it gets me. And the other, then the typically you don't do the unstructured deep learning and the structured kind of queries in the same data set. That's I'm not, you have people who do deep learning and that's their thing. or you just do basic classification. Most of the problems that you're trying to solve in all the amazing thing blobs we saw with many trillions returned from the McKinsey Institute can be done with simple classification. So what you are learning here is the basic classification. So what the auto AI model is going to do is, it is actually going to run the model and try different kind of classification algorithms and say what is the recall, what is the accuracy, what does it look like. And once it is done, you look at it and say, I don't like this, and then you can pick. That you will not be picking, the data scientist will be picking. So the way the data scientist will do is, they will say, hey, can I run a classification algorithm, and they will pick one of the algorithms. Let me go this. I want to give you a few more types of classification algorithms, because I don't want to finish this topic without you knowing a few more jargons that will chase you. So one of the, remember we said about the loss function. So there is one kind of classification algorithm, which is a very famous one, and people love this whenever they talk and teach about machine learning. It's a beautiful graph. It's a very nice thing. So they actually try to minimize the error function. Their error function is what? Loss function is when the algorithm performs in a certain rate. There is a error in when the algorithm is supposed to predict what it's supposed to predict. Instead, it is predicting completely something else, like the donkey. Then that's a huge loss, right? That's the loss function. And your goal is to minimize the loss function and keep iterating again and again and again. The learning rate is how fast you make a jump and make changes to learn. Or are you going to just make small changes and run again, small changes, run again, small changes, run again, then you kind of draw more. So that's the learning rate and the loss function. And again, you don't need to know that, it's just a jargon that's used in the CNN world, or it's used in machine learning when they're running this iteratively, okay? So the data scientist will decide on a certain rate. In fact, the data scientists, even when they are learning, they are taught to make some assumption. Let's take a learning rate of 1 or 0.5 or something. It's a small number, right? So they are given default learning rate to, it's like iteration. You have to go keep doing so many times, and how fast you change to the next cycle. And that is a learning rate. And then you minimize the loss function is what they're going for. And so gradient descent is one of those where you try to minimize your loss to a point after which the loss increases. So they want to arrive at that. And that is one kind of algorithm. So you will hear the name of this algorithm, and it looks like a pretty cool graph. So I wanted to share that with you. And again, for all practical purposes, you don't need to know what is gradient descent, what is this and all that. So you're going to say, I have this one case, I have this one other case, and I just want to compare the two and do the training model. Okay. I think that's all I have in terms of the models. And I wanted to show you in the IBM system and the other one, right? To see whether what does it look. So the auto AI will actually go through 7 different models. I think IBM does go through 5 different models, and will show you. I had that ready set up the other computer. For some reason, this is not signing up. Okay, so I want to pause here. Are you guys seeing what I'm seeing, or I'm not sharing the screen? Did you see the gradient learning, guys? This thing, right?
Yes.
This one I did, and then I got out at this place I closed, right? Okay, so for all practical purposes, what we learned is structured, unstructured data. So you start with 4 different kind of things you can do, and you do machine learning, or you do deep learning and fast forward, or RNN. We saw that, and you can go watch that. Computer vision is object detection, and anomaly detection is kind of arranging the data and then finding the odd men, which is the metrics. You said these 2 we are not covering in this course. And then you're always going to be like structured, unstructured. Are you doing regression? Are you going to do clustering and classification? So between classification and regression, you can solve 99% of your problems. Or you might have a vendor who has done a lot of clustering and is giving you a model and says, believe us, we can tell you every transaction that is fraudulent, and we can get your group like that going. So that is the thing you're going to hear. I would recommend now going back to this teachable machine with google.com and just run something, right? Apple versus anything you can just download from the internet, 2 sets, run it. And then when you do this, you will find the recall and accuracy and stuff that I was telling you, the learning rate, loss function, all of that will be under this advanced. You'll say this. We don't mess with it, we do the default, but you will see that it is there. And then when it runs it, finally it says export the model. So at that point, it will give you the code by which you can run the inference model. Here, we are just visually doing it here, but export the model means you take that model and you host it somewhere, or they have an option to host it. I obviously go with Google is doing this as a learning exercise, so they're not charging. This is where Accio will say, hey, you export the model and you can run it, and we'll charge you. And they will charge you on a per usage basis. So I just want you to be aware what these mean. And like the CNN, the more you learn these things, more you keep seeing this, you're going to kind of get comfortable. It says, yeah, I know what that jargon means and I don't need it, right? You're not going to decide on learning rate. You're not going to decide on loss function. You're not even going to decide on the different kind of algorithms, but you need to be aware whether it's structured and unstructured data. Are they doing some basic are you asking them to do some anomaly detection, which they're not going to do easily for you? And then the other thing you will see is when I show Auto AI, you'll see the IBM model is testing across 5 different classification algorithms and telling you what it looks like. But when you do it without, if you ask the data scientist to do, they will run a model and they will say, okay, it's not performing so well, let me try another model. So I have heard from so many business people who said, my data scientist is too junior, they don't know what they're doing, they keep on changing the model. And it kind of creates a distrust with the data scientist, which is very unfortunate. The data scientist, on the other hand, could say, my business person doesn't know what they're doing because they're not giving me the right data, they're just asking me for something that's not possible to do. So I think that's going to be your biggest challenge, because the way the data scientist is going to operate is they're going to iterate and try different models. It's called model fitting. They're going to keep fitting the model. And it's easy to get carried away and say, this is the best algorithm. Doesn't matter. It might not do the job for you. It's not the best algorithm. And so you should not lose focus on what you set out to build. What is actionable that you want the algorithm to give you, based on which you're going to go act on it. And you define metrics, right? I want to increase churn by 5%. I'm going to test it. This is how I define success with this pilot. And then you might arrive at the full 10% growth only when you deploy your entire data set, but you might do that on a small pilot with a set of customers. So defining those metrics is on your hand, testing that, getting the right data, creating the feature engineering, all of that is in your hand. But picking the right model and whether they're iterating on the model doesn't matter. Whatever the model claims, its accuracy also doesn't matter. It has to be accurate for solving the problem that you're trying to solve for. So you have to know what's the AI confusion matrix and the recall and accuracy. So with the Auto AI with IBM, they actually show me what is the confusion matrix when it runs it. So I know we've gone way past our planned time. We know we started a little late and then we ended up going much longer. Does this make you feel comfortable in understanding the theory of the models? I can actually say these are the 7 machine learning models and explain how the brain of that model works. Remember, John was showing a graph. They typically show a best fit graph and they show dots here and dots there and that, how it's done. You don't need to know all that. It doesn't matter. It's just forming a pattern. It's classifying, it's grouping, it's organizing. And then when you feed it, it's making a prediction. And then it's a training model. Now it's ready for production. It's an inference model. It has a certain recall. It has a certain accuracy. Doesn't matter. That's all for the data scientist to do. Your job is to say, what's the business problem I'm solving? What are the different ways I can solve it? And what is the use case? Which is actionable? What do I have the resources? Is this something I can do? And what are my business metrics? How do I define success with all this? And Then you actually say, look at the data, how, in what format should my data be, and do some feature engineering. Am I going to ask the algorithm to do a yes or no question? Am I asking it to do some kind of prediction on a curve? And or I'm trying to understand the customer behavior to see which factor contributes to the behavior of the customer. Or I don't know what I'm doing. I have so much data and I have aspirations to make money with this data. Should I ask them to do some clustering? Do they know to do deep learning? Whether they're going to do RNN, CNN, feed forward, or some new jargon that they give us tomorrow does not matter to me. Yes, it'll be fun conversations to show that you know what you're talking, to earn the respect of your data scientists, but they're the ones who did the math and came. And then we've spoken a little bit about in each of this, when you get the false positive, false negative, different situations, you have to productize it. How do you give the front end to the user? How do you give a mobile app? What does that look like? How do you cater to the person when you get false positive? And do you lose customers? Is there going to be a lawsuit like the Uber driver firing situation? Things like that. Those are business questions. And then is there are you hoarding data and storing it that you should not be storing? Of course, that's going to be a GDPR and compliance thing. That's going to be on you. So are you crossing an ethical line? Is this something you should be doing just because you can do? Is a question you have to ask yourself all the time. Okay, so with that, I want to pause. Do you want to learn all the different models, what they're called and what does mean? Maybe I can send you material if you want, or I can talk about it later. But I think for a lot of theory, I think we've kind of maxed out on theory now. I would like to show you the Auto AI from IBM and compare it with Accio. But I want to see, I have only a couple of you who are super motivated and are able to stay back also. Do you want to pause? Do you want to take a 10 minutes break and I'll just show you the Auto AI? Will be done with it. I would feel good if I just.
Yeah, I think that would be good to see an
Yeah.
example.
Yeah, I'm good with time. Yeah.
But yeah, I mean, I think if we have like a little cheat sheet on the different methods, it's always helpful. And I mean, what I've done, I compiled on my own a couple of different things.
Yeah.
But I took a machine learning class, but I kind of I forgot a couple of those things already.
Yeah.
And,
so do you want the machine learning? Do you want to know all the different models and what do you want? Like I try to give you the models of how the model works, like in English. Is that what you want, or you just want the names and jargons? As like
I mean, I think like what you had in that in a couple of those slides that you had, kind of the uses.
Yeah.
That kind of makes sense. A little the theory, it's fine too. I mean, you can always dig out more theory. So to me.
Yeah. Okay, so let me give you one more resource. Remember the McKinsey Institute one we saw? I'm going to go back there, but this is a different section of their site. They have created this to say an executive guide to AI. It actually is still talking to the data scientist, or it's talking data science mainly, but it's all right. It's done very well. So it says what is supervised learning, unsupervised learning. I think this is very good to how it is done, how it works and all that stuff, right? And it tries to put reinforced learning as a separate bucket. I don't know why, but it has one of those and it explains that and all that, right? So it shows like, it's a reward environment and the algorithm loops to learn. It kind of does a good job of how it all works type of thing. When is it used? They're not doing much on this for some reason. Maybe they have business use cases. They have a bunch of business cases where the reinforced learning is used, whereas unsupervised learning is used and things like that, right? Algorithms which are unsupervised. I would not worry about what these algorithms are, what this means, but I just think you can poke around and say, what does K-means clustering? Okay, what it segment customers into groups by different characteristics. This is what you were talking about, Emmanuel, right? To better assign marketing campaign or prevention. That's the K-means clustering. So that's the most famous one of them all. So it's good to know, but autoencoder or hierarchical cluster and all that stuff doesn't mean anything. You don't need to know the specifics, but you can play with it, poke around here. The area which is going to solve most of your problem is supervised learning. We've been through how it learns, input, output, right? Human labels the data, algorithm is trained, and then it just spits out the model, and then you test the model, right? This is what all the auto AI guys are going to give you. These are the different kind of algorithms. So we covered linear regression and logistic regression. We spoke about that. The other famous one is a random forest or decision tree. It's just good, or this SVM is another one. So you may just hear these names. So it's good to just go and say, okay, what does decision tree mean? And they will say blah 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 how they will do this, right? They don't have too much. They try to make it like little English version of that, right? And they will say, where do you use it, type of thing. There isn't a clear mapping of what algorithm is used for what situation. I've read many different books, many different tutorials, and there isn't anything. And you ask any machine learning data scientist, they'll get really upset. They'll say, no, there isn't. There are situations when you have less data, what do you do? When you have too much data, what do you do? What model you naturally go towards. Once they've done enough, they would gravitate to something based on their experience. So obviously, the more experience they have, they are going to do better. But then the market shifts all the time. So, somebody new might bring fresh perspective and know the latest algorithms that the other person is not up to speed. But most of your problems are going to be solved within this linear and logical regression. So linear regression, and then understand product sales such as distribution, optimize price points, this kind of thing. See, it's still not telling you the specifics like I was giving, right? How you have to frame your data to ask that question. Logistic regression is on a pattern, right? And so that's the thing, right? Logistic regression is where whether it is black or white, or rather than a continuous. So logistic regression is one, it's going to be on a point basis, and then the other one is going to be on a continuous basis. So it just tells you that if you take the other one that I gave you, where they do the visualization, where it has multiple use cases, and then you look at that, this takes a while sometimes to load if you try to organize it too much. I did a run already, so it's sitting. So you can say classifiers, you can say who is doing regression analysis, and what kind of applications, and then you might want to find those, and then you might find a bunch of this. And you will see some other terms like Monte Carlo and Markov processes. I don't even think you should worry about it. You're not going to be a data scientist. If your data scientist doesn't know that, then that's a problem. You're not the one who should be even talking to them. So this is, they said 9 different kind of regression analysis, and then what kind of use cases and which industry. Again, it's interesting, a lot of things comes to supply chain. The basic classification comes to everything else. That's my observation. So you can play with this, and you can get a sense of the jargons and the terminologies and which industry, what applications, and it'll just help you prepare to know, what you don't know, and which industry you can target, what kind of applications can you do, how can you bring your transferable skills. So this one, I'll give you the URL for this also. I'll put this in our curriculum area also. Sorry. Where is my Zoom? Getting back to Zoom. Yeah. I'm just writing cheat sheet for AI models. So that's a reminder for me to send you guys something. But I think looking at the McKinsey thing would be a great start, that you can play with it. And like the CNN, the algorithm, you're going to learn every time you go. I find that every time I go back, I learn something new. The same thing, I've gone and played with it many times, and then I would be like, why do they explain it this way? And I would explain it this way, or which industry is doing that, and what is this model? I kind of go back again and again. And some of these things, because it's linear regression, logistic regression, it's just do regression. If you don't know regression, what are we talking about, doesn't matter. You just need to kind of go back enough number of times and map it into what kind of applications it's doing, what you will do with it, and then you're golden. Then you'll be able to talk the talk. Okay. So can we take like a 10 minutes break? Is it too much? And then we can come back. I want to show you the comparison between the two, IBM Auto AI and this the Auto ML from John Accio. And
how long is that going to take?
I would say 45 minutes.
Okay.
Do you want to do this now, or you want to do another time? because I wanted to give you a tool to go um, do something with. Or yeah, if you think you've maxed out, maybe we can do it next week.
Yeah, just trying to figure out, um, some of the other stuff I got to do today.
Yeah. Oh,
That's
it's
all.
yeah. Anyway, sun is set for you.
Yeah.
So
Sudha, is this the last class? I mean,
so I was going to finish with last class as the last class. Yeah.
I know.
So what I'm planning to do is I want to give you the actual tool to play with it, and then I want to meet you guys one more time. That will be my last class, because I want you to apply this for on your own data, which you have not done, right? Even if I give you the tool today, I'm going to do it on your data, and so I want you to then apply it on your data, and then wrap up with a nice bow and come back and tell me what does that look like, whether you want to do a demo day. My personal take on this is, you're barely scratching the surface. There is going to be more things that you're going to realize that you need to learn more, or you're going to say, okay, I did this machine learning and I want to do more like NLP or computer vision, or I've learned this, now I want to do next level of complexity. So I think
Right, yeah.
it's going to be an ongoing journey, but I want you to wrap up what you've done, feel comfortable of what you've done, look back, uh, and then we can figure out, where do you go from there. But I'll do one more session. The short answer is I'll do one more session, but I'm going to expect you to do some homework before you meet me again.
Right. So if I can figure out logging into the IBM Auto and try the steps to add the project and all of that,
No, that,
then
yeah,
yeah.
that will be a challenge, because IBM does that. I did that last night again. I had actually done this literally like a couple days back because I wanted to show you guys.
Mhm.
And I had done this with one data set and it
Right,
worked,
right.
right? I went back and I said, no, I want to put a different data set that I'm going to give you, that I want you to do it. I just
Mhm.
couldn't log in. I logged in, but it
Right.
says you create a project and you find your asset and you enter your data, or some 3 steps. For the life of me, I could not find where the project link was.
Would you recommend
Yeah,
going back and using IBM AI? So there are so many no code AI
yeah,
platforms. So would
yeah.
you still recommend to try it out on IBM?
I
Auto?
think it is good to try out because it's a known one. Accio is a new
I
company.
see.
I think Accio has made it really no code, but then they're making decisions internally. They are not going to tell you what model they're using. They're going to say we are running, and they give you a nice UI,
Ah, okay,
and
yeah.
then they're going to just, so would you trust them now? If your business depended on it and you're just saying we've done the model, guys, believe me, and then it works. Just because it works once doesn't mean it's going to work the next time. So
Right, right.
I think it's a bigger black box than auto AI. So I think one is, if you give your data scientist and tell them to do the model and then look at it and ask them questions and work with them, then that's the ideal scenario because there's so much transparency. The other thing is you go this no code AI route based on any of the known platforms, which give you, okay, this is what we have come up with. That's what I want to show you with IBM Auto AI.
Mm-hmm.
And then you can decide, this is still too complex. I'm not going to use it. I'm going to use Accio. It's all right. But I just want you to know what it is doing in the brains of it.
Right. So, yeah, currently I'm still an engineer, so I do try to get into and understand. So,
I think
I love being
make
an engineer, by the
AI.
way. But then, yeah. So this link that you had given us before to set up the auto AI in IBM, so just follow that to see if it works out.
It should work. The only
Okay.
thing is, I think the whole idea is you have to create a project in Watson service. What I'm going to show you is my success story of after done. And literally, it failed on me, right? It would not let me do. You saw me when I got started. I tried to move to another machine. It's not letting me log in with the same login I have. But I'm going to go back to my old machine where it's logged in at least. And I could do the run with the other data set that I want you to try.
So I think you and Emmanuel can decide. I had kept the Saturday open for all
You
of
were
this.
the one who asked for Saturday, so you're going to keep
Yes,
me
yes.
here.
So for
You're going
me,
to
the
keep me
whole
here 9 o'clock.
it's up to you
Okay.
guys.
So Emmanuel, here's the thing. Do you want to take a 5 minutes break and then I'll show you the difference and stuff and we'll wrap up by 4?
Yeah, that's fine. That's fine. Just ideally, I would like to be done in the next 45 minutes.
Yeah. Okay. Let's take a 5 minutes break and we'll wrap up by 4. 7
And
o'clock.
now the link you just sent. Do I need to log in or sign up?
To the IBM one?
Yeah.
No, don't. That will not be done in 45 minutes.
Okay.
I'm going to show you the IBM one, and I would recommend just, um,
So
having
this is the one you want us to play with?
the IBM one is something I want you to play with, but it will take a lot many hours and it will break on you.
Yeah,
Again,
the website has some login issues, so that's why I'm just trying to kind of, you know, see how it is, and then I can figure out some, like, maybe just be incognito mode or some
it
some
won't matter.
hack to make it.
I did that exact same thinking, right? I said, oh, it's because of my cookies, and I accepted that I didn't want all the cookies and then, selective cookies. And is that why it happened? It has nothing to do any of it. Their site is so complex and they're trying to dumb it down and give us a very nice clean view in the front, and they keep on adding more things, and they rename their products. They need product managers. Ananya, maybe you could, if you crack this with IBM Auto AI, you can go work for them. They have an issue, I think, productizing it right, because they keep adding more products and they say, what we used to be called this, now it's called something else. So I paid for a course, learned this whole, what is CNN, what is machine learning, what's the whole thing, how do you do this with IBM as the platform. And then I went back to my lesson. Everything has changed. My lesson is, I paid for the class with unlimited access. Now I can't use it because it's all changed to some different names. And the instructor is walking me through in terms of what the visually the steps would be, and it's not working. So Emmanuel, let's take a 5 minutes break. I would not recommend you do the Auto AI. I can walk through it and give you a new video, guys, if that will be useful. Step by step instead of the IBM video, and say, here's what I'm doing. Here's I'm logging in. Here's I'm, and watch that and follow through and see if you run into issues, and then I'll help you one-on-one.
Okay.
But not now live. Because I want you to see what Auto AI is doing and what it's doing behind its brain. That's my goal, to show you that. And then you can try something with Accio. That will be the easiest.
Yeah. Okay.
Yeah. Okay. Let's take a 5 minutes break and we'll come back, and I still will finish up in
Okay.
by 4. Yeah.